Today we'll do zinc phosphate cement. Zinc phosphate cement is one of the oldest cements to be produced, and it is used as a standard for the newest cements to compare them. It is used as a standard for comparison to newer cements. It is also called as crown or bridge cement or even ortho zinc phosphate cement. Now coming on to the uses. It is used for temporary restorations, high strength bases, for luting purposes, luting onlays, inlays, fixed dental prostheses. It is also used for cementing orthodontic bands and brackets. It is of two types based on the grain size. So this is the third one, fourth. Based on grain size, type 1 fine grain, type 2 medium sized grain. This one will be used for the luting purposes, and type 2 will be used as base in deep cavities. We've done the uses this, and the ISO classifies it into two types, that is luting bases and lining. It is available as powder, liquid. Now coming on to the powder. The powder contains ZNO, MgO, then certain oxides like BaO, CaO, then silica. The liquid contains obviously the phosphoric acid, water, aluminium phosphate. Aluminium phosphate has an important role. We'll see it in the setting reaction, Al and Zn. The ZNO is present is 98%, MgO is 8%, then oxides are 0.2%, and this is 1.4%. The orthophosphoric acid is 38%, water is 36%, aluminium 16%, 2.5%, and 7.1%. The uses: this is a principal constituent, then this aids in sintering. These oxides improve the smoothness. This is used as a plasticizer and a filler which helps in sintering. Phosphoric acid main reactant which reacts with ZNO. Water, it controls the rate of reaction. Al2O3, it buffers the reaction. Okay, this is the composition. Now coming on to the manufacture. How is this cement manufactured? The ingredients, they are mixed and heated at a temperature of 1100 to 1400 degrees Celsius, that is sintering. Then they are cooled which leads to fractures. Thus it helps in more efficient grinding. This is called as fritting. This process is called as fritting. Now coming on to then the liquid. How is the liquid produced? The liquid is produced by adding aluminium or zinc in the orthophosphoric acid. So what is the procedure of it? In procedure, you get to see that we use a stainless steel spatula. Stainless steel spatula is used. These are the basic things that I'm telling you. Then I'll tell you the procedure. The water powder ratio that we take, the liquid powder ratio or the powder liquid ratio, more precisely powder liquid ratio, it is we take 1.4 gram of the powder in 0.5 ml of the liquid. Okay, now coming on to the procedure. A cooled glass slab is taken. Cooled glass slab is taken so that it will delay the setting time. Then they both are the powder and liquid. The powder is added in with accrements into the liquid. They are mixed using a stainless steel spatula in a brisk circular motion, for 15 to 20 seconds. Then it is observed that in the initial 30 minutes, the cement gets 70% of its maximum strength, which is enough for luting purposes. Okay, now coming on to the working time, which is 2.5 to 8 minutes for luting, that is type 1, and 2.5 to 6 minutes for basis. Now the procedure is done. Now I'll tell you about the setting reaction. In setting reaction, what actually happens is the phosphoric acid attacks the powder, which has Zn as the basic constituent, and releases Zn2 positive ions. Okay, first point. Then aluminium, which is already present in the liquid, aluminium attacks or bonds with phosphoric acid. Then zinc ions, which were released here, get incorporated. Then they form zinc aluminophosphate. I'll simplify it in an equation. See, we have aluminium, we have phosphoric acid, we will form aluminium phosphate, then we'll add Zn ions to it, we'll form zinc aluminophosphate. This is what is responsible for the reaction. Now the zinc aluminophosphate, okay, this has a cord-like structure. Now how can you actually affect the setting time? Suppose if you take more of the liquid, suppose liquid is more, the setting time will be delayed. if you take more of H2O, okay, if the size of the particles is small, size of particles is small, then also the reaction will take place rapidly. The reaction rate will be high because you will provide more surface area. Okay, then it also depends upon the rate of powder being mixed with acid and many other factors. Now coming on to the properties. Properties may first of all compressive strength. Compressive strength is high. The tensile strength is low, a weaker one, low or weaker, due to which it is brittle. Coming on to the fourth, that is modulus of elasticity. It is high, so it can resist the fractures, adhesion and integration. The main principal mechanism is micromechanical bond. Now the acid bonds with the set cement, due to which retention is produced in the oral tissues. Then fifth is solubility. It is seen that it is highly soluble in dilute organic or inorganic acids like lactic acid, citric acid, which are usually present in the human diet may they are present. So what happens is, these dilute organic acids, they solubilize the cement, thus this does not remain integrated and cannot and is highly indicated again and again to be replaced. So this is what happens in solubility. Then on sixth is the biocompatibility. In biocompatibility, it is highly acidic because of the phosphoric acid, highly acidic. When it sets, the pH is around 2. After some time, the pH decreases later. Okay, this is, and the dentine, if it is not protected, if it's not protected by some varnishes, protected, it has a thickness of 1.5 millimeter thickness. The acid can penetrate and produce pulp irritation. Now a very important part, zinc phosphate has some advantages and some disadvantages. Coming on to the advantages, it has a good track record and is reliable. Coming on to the disadvantages, it has poor aesthetics since it is opaque, so it cannot be used for translucent prostheses like all ceramics, crowns, veneers, etc. Then it also produces pulp irritation or inflammation. Then it is also it fractures quite easily since it's brittle. Then it also has a property of solubility, and the adhesion is very less. Because it can adhesion is less. Therefore it is not indicated where retention is less. Over here it has a good compressive strength, as we mentioned in properties. This is the entire thing. And one more important, it has no anti-karyogenic property. It has no anti-karyogenic property. This completes the zinc phosphate